Welcome. Dear student, we are discussing about the physical techniques for synthesis of a nanomaterial. In previous lecture, we discussed about the ball milling method. Friends, in this lecture, we have to see what is physical vapor deposition technique. So, physical vapor deposition techniques, generally there are two deposition method. First is a physical vapor deposition and second is a chemical vapor deposition. The vapor is deposited on a substrate to form thin film. So again, a physical vapor deposition have a different types. First is a vacuum deposition. In this method, the vapors vapors of a material is deposited on a substrate in a vacuum chamber. Second is the ion planting method, then sputtering method, ion beam sputtering method, ion beam assist method. If we consider chemical vapor deposition, there are again three types. First is a thermal chemical vapor deposition. Second is a light chemical vapor deposition. And third is a plasma chemical vapor deposition technique. We have to see what is this physical vapor deposition. Physical vapor deposition is a process in which the material is converted into the vapor phase. Okay. The material is heated, okay, so that it is converted into the vapor phase in a vacuum chamber and condensed onto the substrate surface as a thin film. Okay, we can use a glass plate as a substrate. Okay, and the material is heated, it is converted into the vapor phase, and this vapor are condensed onto the glass substrate, or we can use stainless steel as a substrate to form thin film. Okay, this is a diagram which shows there is a material. The material can be placed in crucible, it can be placed in a boat, or we can use rod of a material, we can use a spiral spring of a material. Okay. This material is heated. Okay. The material is heated up to the melting point of that substance or material. Okay. So depending on this heating, there are again different types. Okay. First is a direct heating, in which the uh, the material is in form of a wire or a rod, and the electric current is passed through this wire or rod so that it is heated and evaporated. Second is indirect heating. In an indirect heating, the material which we have to evaporate is placed in a boat or crucible. Third is a inductive heating. In an inductive heating, the electromagnetic induction phenomenon is used so that the it is converted into the vapor phase. Then laser evaporation. Now The laser beam is incident on the material so that it can be evaporated. Now this process is carried out in a vacuum chamber, and the pressure inside this vacuum chamber is about 10 raised to minus 3 torr. We know that 1 torr, it is equal to 133.322 Newton per meter square or Pascal. So this is a vacuum inside, a pressure of the vacuum inside the vacuum chamber. Now the material is heated, it is evaporated, so and the evaporated molecules are condensed onto substrate film so that we get thin film. So very simple method, physical vapor deposition techniques. So here the heating process is carried out. Okay, the material is placed in a boat. Material is placed in a boat, and this material is heated. Okay, and the evaporated material is deposited on the substrate. Okay, now physical vapor deposition involves the following steps: synthesis of a coating vapor. Okay, then vapors transfer onto the substrate, then the condensation of the vapor onto the substrate surface to form a thin film. These three processes are very important. First is a synthesis of a coating vapor. Okay, synthesis of a coating vapor. It indicates that there is a formation of a vapor. Okay, so there is a heating process is carried out in this step. Okay, the vapor is a transfer to the substrate. Vapor is a transfer to the substrate. Okay, in a vacuum chamber, all these steps are carried out inside the vacuum chamber so that the evacuation of a chamber is required for physical vapor deposition. Therefore, the vacuum chamber is evacuated. Then vapor is condensed onto the substrate surface to form a thin film. Okay. Next is there are two important types of physical vapor deposition process are. First is evaporation, in which the material is evaporated. Okay. Second is a sputtering. In evaporation, we use direct heating, indirect heating, inductive heating, then laser evaporation. And in a sputtering technique, we use the inert gas such as argon is an incident on the material. This process we have to discuss in a next lecture. Sputtering technique. Okay, this we have to discuss in a next lecture. Okay, now evaporation. The material is evaporated into the in boat or crucible. In order to evaporate the material, it must be heated to a temperature at which the vapor pressure is a 10 raised to minus 3 torr or higher. Okay, material is heated. Okay, material is heated up to the melting point of the material, and this process is carried out in a vacuum chamber in which the vapor pressure is about 10 raised to minus 3 torr, or it may be higher. And the thermal evaporation process. Thermal evaporation use the heating of a material to form vapor which condense on the substrate to form a coating or a thin film. The heating is achieved by various methods including hot filament, electrical resistance, electron or laser beam and electric arc. Type of thermal evaporation according to the input energy is: first is a direct resistive heating, second is a indirect resistive heating, third is a inductive heating, fourth is a laser ablation or a laser evaporation. Thermal energy given to the atoms in a liquid or solid so that it is converted into the vapor form. Okay, the evaporated particles can travel directly toward the substrate without colliding with the background uh, gas. Okay. Now, direct resistive heating. In this method, the material is direct evaporated by high electric current. The material can be in a shape of a wire or a rod. Okay, the material is in a shape of a wire or rod, and when the electric current is passed through the wire or a rod, it get heated, and this wire and rod is evaporated. This method is only used for materials such as carbon, then ceramic, Fe, Mo, nickel, PD, RH, titanium, aluminum, etc. etc. Next, this is the wire. Okay, when the electric current is passed through this wire, it get heated so that it can be evaporated for higher current. Next is a indirect resistive heating. In this method, material is put in a container, that is both spiral wire, a ribbon or crucible, and then it is heated up to it get evaporated. This is the crucible. Now, inductive heating. In this method, the material is heated by high frequency induction. Okay, the evaporated material has to be conductive. The evaporated material has to be conductive, and we use the electromagnetic induction phenomena. Okay, so it is heated. That is when the electric current is passed through this material, some AD current is produced. Okay, so this method is also used in a inductive furnace. Inductive furnace. Okay, so inductive furnace in which the material is heated by high frequency induction. Next is a laser evaporation or laser ablation. In this method, the continuous interaction of laser radiation with the matter can lead to thermal evaporation. When laser beam or laser radiation is an incident on a matter, okay, the heat is produced and there is a thermal evaporation of the material. Now there are some advantages and disadvantages of this physical vapor deposition. We have to see all these one by one. First is it is a simple and cheap method. This is one of the advantage. Simple and cheap. It is less surface damage of the substrate. Okay, the very less surface is in contact with the vapor, and so that the less surface damage of substrate. Then it is excellent purity of a flame. Okay, there is a no contaminations, there is a no, this is a environmental process in which the impurity is not added from the surrounding, and therefore there is excellent purity of the films. The purity of films is depend on purity of a source material and quality of the vacuum. Okay, the source material is pure, then the film which prepared by using physical vapor deposition is also pure, and the quality of a vacuum. Now the thickness of the film can be vary according to geometry of a chamber. The chamber geometry of the vacuum chamber is changed, then the thickness of the film can be also changed. It is also depend on the evaporation temperature, okay, the evaporation process and the vacuum. Okay, now there are some disadvantages of this physical vapor deposition technique. First is a limited to low melting point metals. Only the metals which melt at a particular temperature can be we can prepare the thin films of that material. So limited to low melting point metals. Okay. Then poor density and adhesion of the film. There is a poor adhesion, okay, between the films and the material. It is not possible to evaporate dielectric material. The dielectric material cannot be evaporated by using this method. Okay. Application. It is the evaporation of metals, alloy, semiconductor, and insulator. Okay. So we can evaporate metal, alloy, semiconductor, insulator, and this can be condensed on the uh, substrate film. Then the it is also used in a gold plating. Then thermal insulating coating can be done by using this by using this method. Okay.